an accident, what percent did not have an accident?
99.
Yep, no accident. Right, so here this was 5%. 5%, 5 cents had an accident, no accident, 95%. And here was 9% had an accident, so 0.91 did not have an accident. We want these ones here. How do you find this spot here? 0.60 times 0.01. And you guys got 0.006. Here you did 0.30 times 0.05. And you got 0.015. And then this last one you did 0.10 times 0.09. And you got 0.009. Now, I want to know how many people got in an accident. You could be a low risk and get in an accident. Well, first of all, can I be a low risk driver and a high risk driver? No. I could be a low risk driver or a high risk driver, right? So I could be a low risk driver and get in an accident, or I could be a high risk driver and get in an accident, or I could be a medium risk driver and get in an accident. Is everybody with me on this part? So you could be a low risk or a medium risk or a high risk. Or as we add. So if you add these up, you will get 0.03, 3%. Good? Does that make sense, folks? So this is a combination of and. You're a high risk and you had an accident. Low risk, medium risk, and you had an accident. And you multiply. Ors. So then we find all these numbers, and then it's this, low risk and accident, or medium risk and accident, or high risk and accident. Ors we add. Good? Yeah.
Is that 3% the same as the last question, like if the driver selected at random?
No. Oh, yeah. It's not the challenge, but it is the question, yeah. So this is the question, that's this question here. 0.03. Yeah. Now the challenge is different. If someone has an accident, find the probability they're a high risk. So that means that if someone had an accident, if they're in this group here, what's the probability they're high risk if they're one of these groups here? So how do you get to this group here? There's 3% that are in this group. Half of them come from medium risk. Do you guys see that?
Yeah.
When I add these all up? So if you're in an accident, there's a 50% chance you're in the medium risk group, because they're a fairly large group, and it occurs reasonably often. So how do you get that? Because you know that half of it came from there. If I want to know about the high risk, I need to find out the proportion of this over the whole. Because this would be 0.15 over 0.30, 15 over 30, that's half, right? Half of them came from there. 9 out of 30 came from here. So do you see what I'm saying? So how do we find this? We do the 9 divided by the total. So this part here is 0.009 divided by 0.030, and you get, I think it's 20%. No, that can't be right. Sorry, 30%. 30%?
Yeah.
30%. Yeah, it's 30%. So 30% chance. If you're in an accident, there's a 30% chance that you're a high-risk driver. There's a 50% chance that you're a medium risk, because there's just a lot more medium risk people out there. And there is a 20% chance you're a low-risk driver. Okay. So now we're going to talk a little bit about our conditional probability and Bayes theorem. So that's your next thing going down your sheet. So this is a conditional probability. The probability of B given A is the probability of A and B divided by the probability of A. That's what we just found a second ago. Right? We found, but where does this formula come from? So, do you guys remember this formula here? Right? Probability of A and B. Probability of A times probability of B given A. That's just that multiplication probability we found. If we take both sides and we just divide by probability of A, then this part will cancel out, and I'm left with probability of B given A is equal to the probability of A and B divided by probability of A, the part up there. So it's really the same formula, you know, just we've just divided by probability of A, and it shows you kind of how to solve for it. Kind of like how someone over there earlier today was saying, I think it was Noe, was saying, well, can't I just, you know, swap these two? And you can. It's just it may change it to a different formula, but still a valid formula. It's just an adjustment. When you switch, you take the probability of A or B, and A and B, you swap them down, like that. It's just a rearrangement of this one you already know. It is also kind of a simplified version of Bayes' theorem, which we do need to cover in this class according to UC's. So Bayes' theorem is just, it's a slight adjustment. It's the same thing, right? Only the question is, right, this is the probability of high risk, given you had an accident, the 30% thing we found at the end, is probability that you are high risk and had an accident divided by the probability you had an accident. The only adjustment we made is, this is the probability that you are high risk and had an accident. How do you find the probability that you're high risk and had an accident? You take the probability that you're high risk and multiply it by the probability that you had an accident given your high risk. Okay, you guys are like, what? How did I find this number? Probability you had your high risk multiplied by the probability you had an accident given your high risk. Yeah?
So would that be the probability of B given A part?
Yeah.
Okay.
Yeah. And so it's just the probability that you're high risk, given you had an accident, times probability that you're high risk. It's just multiplying two of those things together. Right. Probably you had an accident, given your high risk, times probably that you're high risk. So that's just the, you know, that's Bayes' theorem. It kind of perpetuates that, but that's the basic form of Bayes' theorem. We are not going to really cover it in this class. I've kind of thought about it and I'm making a lot of adjustments this semester because, you know, times are changing. And one of them is I'm going to show this to you a little more in a slightly more complicated way, but we're not going to have any homework problems on it. It needs to be covered because it is in our agreement with the UCs and the Cal States that we'll cover it. So I've now covered it, which means that we're going to skip this part here, this next part here, at the bottom of your page. So you can just put skip right along there. So we're going to skip that. So write large letters skip right through there. And then also flip the page, turn the page over. Lab problem 1, we're going to skip that problem also. I am 98% certain I have removed this from your homework. If I have not, let me know and I'll remove it. It's this Avinalia Club Bridge and Swim stuff. So I'm almost certain that I have removed that. All right, so that brings us to lab problem number 2. Oh wait, actually before we do that, let me show you. It's interesting. This is not required at all in the so I'm just going to take a minute. So 5-card flush and poker. It's just interesting. I thought I'd mention it. So there's 2 ways of calculating the probability of getting a 5-card flush. 5-card flush is when they're all the same suit. So for example, you can do it one of 2 ways. You can either say, okay, probability that the first card is a spade. There's 13 spades out of 52. Once you draw that, you can't draw it again. So now I have 51 cards, and only 11 of them are spades. The next card, you draw that one. Now there's only 50 cards, and only 11 of them are spades. The next one, there's only 49 cards, 10 of them are spades, so that's probably of getting a spade that time. And the last one, there's only 9 spades left out of 48. You'd multiply these, because it's spade and spade and spade and spade and spade. And there's 4 suits, so you have to multiply by 4, because you can do that once for each diamond, heart, club, spade. Or you could look at it as, doesn't matter what the first card is, the next card, there's only 12 left of that same suit out of 51, and so forth. So there's 2 different ways of, they both end up with the same answer, but it's kind of interesting. Also not important at all in terms of your education, unless you're going to, well, even then it doesn't take 1,000. All right, so now, this is lab problem 2. Do this. Here, we're drawing, it's the exact same as your quiz, except we are now not replacing the marble. We're going to draw it. Actually, it's not the same as your quiz. It's the same as we did last class. We're not replacing it. So here I have a bag. Pretend like the whites are blue. I have 10 marbles in them. What could I possibly draw?
A red, green, or blue.
A red marble, a green marble, or a blue marble. Red, green, or blue. You should have 3 different, because we're gonna do it where you combine them. You take all the reds, make them 1. Take all the blues, make them 1. Don't have a separate one for each blue and each red. And then we don't replace it, right? I take a marble, I draw a red one. Now how many marbles do I have, guys?
10.
I've taken one, I'm keeping it.
9.
I only have 9. How many are red? Left? There's only 2 red left. Everyone see that? So now these are dependent upon what you drew first.